Hello, and thank you for joining us on Space Nuts, a show about astronomy and space science, and as my brother put on our sticker, stuff. So we talk about all of that, and today we'll be talking about gravitational wave detection because something big has happened. And Fred was at a conference to discuss this very discovery, so we will be getting it from the horse's mouth. Not that he's a horse, but, you know, if he was, he'd be a thoroughbred. We're also going to look at a problem with the SpaceX capsule because the toilet broke. See, this is what happens when you don't pay the rent. Anyway, we'll find out what they had to do about it. It wasn't pretty. It was not pretty. Involved spoons and all. No, we don't want to know. Space doogies everywhere. We'll also be answering questions about the Big Bang, sound in space. It's a theoretical question. And whether or not humans could live on the gas giant moons of Titan and Io. I don't think I'd like it very much, but could it happen? So we'll get into all of that. My name is Andrew Dunkley, of course, your host, and joining me as always is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. Good to see you again.
Good to see you too, sir. Mm-hmm. Now, a little bit of homework. We got a message because we were talking about radio telescopes last week and the 60th birthday of Parkes, and we talked about the first female radio telescope astronomer, but I think we left out radio telescope and referred to her as the world's first astronomer, which somebody picked us up on. So it was our glitch, just a slight glitch in the dialogue. But yes, we were speaking about a lady who was the first female radio telescope astronomer, correct?
The first female radio astronomer, that's right. Gosh, I was getting Ruby Payne Scott.
You're having a week for it because I heard an interview you did on the radio last week with a colleague of mine on our radio station, and don't tell anybody that Fred forgot the name of his own book. You didn't hear it from me.
There was a good reason for it, actually, because Marnie was walking through the front door laden down with shopping bags and clearly needed help.
That'll do it every time.
And that diverted my attention from whatever the book's called.
Yeah, we might be able to mention that later.
Yes.
But let's talk about this incredible discovery concerning gravitational waves. Now, gravitational waves are only a very recent discovery in astronomy. And we detected a certain number of them up until recently. And now, wham, bam, thank you, ma'am, they've just absolutely smashed it out and announced the discovery of 35 more from various sources. And you were involved in a conference about this only recently.
Yeah, yesterday, that's right.
Yeah.
Although the conference wasn't about this work, it was actually about Chinese and Australian collaboration in astronomy. It's a very, very fruitful area with some marvelous Chinese astronomers who are involved with the research. And we had basically some update talks, and one of them was about gravitational waves. In fact, it was slightly different. The one which we were the talk I was at was about continuous gravitational waves. Now, by that they mean detecting things like the wobble of a neutron star as it rotates, because that would be a continuous process, rather than what's been detected so far, which are all the results of high energy collisions between mostly neutron stars and black holes. So it was interesting, actually, Andrew. It harked back to a conversation you and I had probably a month ago or 2 months ago about mountains on neutron stars, which are less than a millimeter high. And the fact is that a mountain even that small could possibly produce gravitational waves, really? Because it's as the thing rotates. It's not a perfect sphere. It deviates from a perfect sphere, and so there's an acceleration there. And the trick is to look for these continuous gravitational waves being emitted from those, which haven't yet been detected. But in the talk, it was given by actually one of the Australian participants in the, I think it's part of the OSGRAV collaboration, which is Australia's contribution to this work on gravitational waves. And so he did mention the announcement a couple of days ago about exactly what you've said, that in the latest run of LIGO and some of the other, one of the other gravitational wave detectors around the world, which is Virgo in Italy, that has netted, as you said, a further 35 new detections of gravitational waves. But the milestone I thought was worth celebrating is that, given that the first one was discovered in 2015, it brings the total now to 90 detections. Most of them are created by merging black holes, but there are also the possibility of neutron stars colliding. That's actually been detected, and neutron stars being gobbled up by black holes, which has also been detected. So it's really the science of gravitational wave astronomy has matured really quickly to have 90 of those events. And what highlighted it for me was 2 years ago, I published Cosmic Chronicles, a user's guide to the universe, which everywhere else in the world but Australasia is called Exploding Stars and Invisible Planets. And I know some of our listeners have seen that. But I had a chapter in that on gravitational wave detections. And I think at that time, I should have checked back in the book, but I think there were 10 altogether. Now, 2 years later, and we've got to 90. It's fantastic to see all this, and we're learning about the different sorts of objects that are providing these collisions. Something I mentioned to you in the email as well that staggered me. So when I read the report about this announcement that there's a total of 90 been discovered, I looked at the original paper, the research paper that is actually releasing this data. And the first 10 pages are lists of authors and their affiliations. I didn't count them, but it would be several thousand, I think.
We've talked about this before. The scientific papers usually have multiple authors, but when we say multiple authors, we're talking hundreds and some, as you said just then, possibly thousands at times.
Yeah, it's extraordinary.
Incredible. All those trees suffering just so you can get your name put down. One thing that I noticed in this revelation of these 35 new gravitational waves that have been discovered is they can account for most of them, but one has a mysterious origin.
Well, yes. The problem is that, we've got, physics tells us how big black holes should be and how big neutron stars should be, but the observations tell a slightly different story. And there are some of these that are really quite mysterious. I'm not sure which one you're thinking of, Andrew, because there's at least one that's generated a black hole whose mass is 145 times more than the sun, and that means that the two black holes that contributed to this were both very big, and possibly bigger than might be expected from what are called stellar mass black holes, ones that are created by the collapse of the core of a dying star.
I'm just going to stop you there. Can you hear that? That's Fredo, our resident frog. He's a green tree frog, and I think he's taken residence in our water tank, which is just outside my window.
Oh, fantastic!
And we've got storms around at the moment, so he's getting very excited. So if we get interrupted by thunderclaps or Fredo the frog, that's why. So sorry.
Very
please
good.
Continue.
No, that's all right.
Actually, I might just make a point. Of these 35 from the report I've read, 32 were caused by two black holes merging. 2 were likely caused by a neutron star hitting a black hole, smashing into a black hole. And then they're saying 1 was unknown.
Yes, that's right. And you can kind of imagine that, because what they do is they analyze the waveform of the gravitational wave as it goes by. And that you can tease out what's actually happening there. I think the way I read it was, rather than unknown, I read it as ambiguous.
Oh, okay. Could have been one or the other.
Yeah. So in particular, it's one that's basically an object, a black hole, 24 times the mass of the sun. Something lighter than that with a mass of 2.83 times the mass of the sun. Now, the ambiguous bit is that object with 2.83 solar masses a black hole or a neutron star? And that's the mystery. It's because the limit on neutron stars is less than 2.83 solar masses. I can't remember what it is. It's about 2, I think. And so, to get a neutron star that size is a mystery. I think that's probably what you're referring to.
Yeah, I
because something that size should collapse to a black hole.
Yeah.
But the feeling is that it's actually a neutron
maybe it was
star
on its way to doing that when it got absorbed.
Maybe so. Maybe got gobbled up at the critical moment.
Someone will probably think of this question, so I'll preempt it. Why is something so small as a neutron star creating such significant gravitational waves? Is it because of the density, the high amount of gravitational pressure existing in that body, and when it hits a black hole, kaboom?
Yeah, yes, that's right. It's neutron stars are they are extreme gravitational objects because their diameter is 10 kilometers or something like that. And it's that sort of gravitational well that stirs up the gravitational waves, if I can put it that way. So what I guess another way of putting it is that if it was a black hole gobbling up a 2.83 solar mass normal star, then you wouldn't get the same gravitational energy being released,
right?
Because I think I'm kind of making this up as I go along.
It's space nuts. That's what we do.
Well, that's what we do. Yeah. But I think it's all about how steep the gravitational well is, and in other words, how compact this gravitational source is, if I can put it that way. Thinking of gravity as a stream of gravitons, which we don't know whether is the case yet, but it might be the way it goes.
Yeah.
So yeah, extraordinary stuff. Look, the physics is really quite amazing, and the fact that we can detect these things at all is staggering.
Yeah.
The sensitivity of the LIGO works. It's got 4-kilometer laser beams bouncing backwards and forwards between two mirrors, whose separation is measured to, I think it's about, if I remember rightly, about 1/50,000th of the, with an accuracy of about 1/50,000th of the diameter of a proton. It's crazy stuff.
Yeah.
Crazy stuff.
And one of those things that, once again, just gives you a headache because you can't get your head around it. Dumb question. Someone asked me to ask you. Why have gravitational waves become such an important thing to study?
Well, we've always known there would be. It's only that now we've hit the technological gateway that allows us to do that. The technology of gravitational wave detectors, which has been struggling along for 40 years, 50 years perhaps. In 2015, with Advanced LIGO as the name of the project, they actually managed to attain this sensitivity that I've just mentioned. It's all about how accurately and reliably you can measure the separation of these pairs of mirrors. And that is now possible in a way that it wasn't. When you think of, you've got to get rid of earth tremors and all of that sort of stuff as well to make the measurements. But now the technology, and I guess to some extent the computational technology that we have as well, has improved to the level where it's possible to detect them. And so that we've now got this flood of events coming in. The detectors are constantly being improved in their sensitivity, and that's why people are talking about continuous wave gravitational waves, because it seems likely that we'll start to pick them up at some point down the track. Yes,
and just like exoplanets, which, we're only 25 years down the track and we know there's thousands of them at this stage. I suppose 20 years from now, we'll probably be in the same situation with gravitational waves.
Yes.
And hopefully we'll be able to learn a lot from them, which would answer some of the many mysteries of the universe. Who knows?
Yeah, that's right.
Okay, we'll leave it there, but obviously there'll be a lot more to talk about in the future in regard to gravitational waves. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Space Nuts.
Now, if you would like to become a patron, as I've said before, it's purely voluntary. There's a good reason to dip your toe into the water of becoming a patron at the moment, because Patreon and Supercast, both services that we use, are offering 30-day free trials for premium access. So if you've been thinking about it but you're not sure, well, here's an opportunity to give it a go for 30 days, see if you like it, and go from there. But yes, that's through Patreon and Supercast. Now, I noticed a couple of things popping up on the Space Nuts podcast group on Facebook recently, where some of our patrons received gifts in the mail, much to their surprise. Yes, we've introduced a reward system. I did tell you we were working on some concepts. We've finally nailed a few down. So people who stick with us for a few months on Patreon will receive Space Nuts stickers. And then after 6 months, we'll probably send something else. And if you stick with us for 12 months, well, we'll give you Fred's Lamborghini. No, he actually drives a Tesla. But it's a Fiat, isn't it? I don't know. But yes, there are presents involved in being a patron, and we're working on a similar concept with Supercast. So if you'd like to try it out, go to our website, spacenutspodcast.com, and click on the supporter tab and go from there. But like I say, it's not mandatory. We're not going to make you do it. It's purely voluntary. Now, Fred, to our next story, and that is of great concern to space travellers, and that is a broken toilet on the SpaceX capsule that was, visiting the International Space Station. This is a big concern. Space doogies are filling my brain. Actually, it's full of that all the time. But what happened?
Yes, it's a fault on the capsule. The SpaceX's Crew Dragon capsule has got a broken toilet. It's docked with the International Space Station at the moment, and this coming weekend, it's going to bring 4 astronauts back to Earth with an inoperative toilet, which was actually spotted back in September, but they haven't they haven't actually made any attempt to fix it.
Yeah, well, there aren't that many space plumbers around.
No, there aren't. That's absolutely right. It's a tube that has come unglued, and that sounds like bad news when it's connected to a toilet.
Why don't they take blue tack with them? I mean, that's
they might
amazing.
have, but yeah, all this is underneath the floorboards of the capsule, or at least the internal cladding. So there's there's a capsule sitting on the ground awaiting liftoff, which has had this problem fixed, but the one in orbit has a do not use sign on it. And so apparently there's no structural compromising of the spacecraft itself. It's going to be fine to bring the astronauts back to Earth, despite the leak. But the astronauts themselves will have to wear what are being called absorbent undergarments.
Yes, well, they've got other names: diapers, nappies, crab catchers. Right. They could be anything. There's an actual double whammy to this story, which I think is very, very concerning. I'm
sure you're about to say the same thing as what I have.
They've just grown their own chilies on the space station. They ate them in tacos they made on board. Now they've got to sit in this stuff.
Oh, dear me. Oh, no.
Oh, that's it could not be worse. I mean, that's the worst timing ever.
So you're quite right. They've grown the first chili peppers in space, which the female astronaut, Megan MacArthur, she described as the fact that they've grown these chilies as a nice morale boost. But she goes on to say they have a nice spiciness. A nice spiciness to them, a little bit of a lingering burn. Oh, God. Anyway, they have 20 hours in the capsule without the toilet. So,
gosh. Yeah, look, I don't think I can hold it for that long.
There was another comment she made. Yes, she described the situation as suboptimal.
Suboptimal.
Yes, but manageable. Suboptimal, but manageable. Anyway, we've had a good laugh at their expense.
Yes, we have.
I hope they're safe and everything goes okay. I suspect, Andrew, bodily fluids are pretty well something that you just take for granted when you're in space, because it is such a different environment from what we're used to here on Earth.
I remember some years ago we had a NASA astronaut visiting Dubbo. He was part of a Rotary program, and he was touring Australia, and he came here and did some special appearances, and I got to interview him on the radio and take audience questions. What do you think the first question was?
How do you go to the toilet in space?
How do you go to the toilet?
Yes, exactly.
I mean, it's vacuum packed, isn't it? I mean, you can't just go like you do on Earth.
No, that's right. No, there's all sorts of things happen. They freeze dry it, actually.
Yeah. Well, we saw that portrayed in the movie The Martian. It was freeze dried and put in little, aluminium packets or something, because he reconstituted it to grow his potatoes.
Yes.
Of course, there is a plus side to all of this, Fred, and that is that if they need extra boost for decel, they can just turn the toilet on and all will be well.
I don't think so. I think they'll leave it well alone. They'll just have one of those signs that you occasionally see in shopping centres: toilet out of order.
Oh, not occasionally. It's a very common problem. Yeah. It just goes to show you the complexity of space travel, though, doesn't it? You've got so many things happening all the time, and it's probably a good thing that the only broken part is the toilet, because you can go without that for a while.
Yeah, you can.
You can't go without your retro rockets and your boosters and your navigational systems and everything you need to re-enter the Earth's atmosphere, or get out of it for that matter. So, we take it for granted today, but it is really a complicated process to get off the ground, get up into space, dock with the International Space Station, swap everything out, grow chilies, and then get back to Earth and hope your nappy doesn't leak. I mean, it's really,
story.
really a complicated system, and I applaud them. I mean, we're sort of accelerating through a phase where space travel is going to become so very common that it will just be an everyday mundane thing we don't even think about, like planes flying over. We don't even think about that anymore. It's just the way it is.
Is the great model for how space travel will be. I'm sure that's right.
Yeah. Well, we wish them well on re-entry and hope that everything stays intact. And all I'll say to them is, if you can hold it, hold it. Because I don't like the idea of red hot chili peppers on re-entry. That just does not do it for me at all. Okay.
Nope.
We will carry on. This is Space Nuts. Glad to have your company. Andrew Dunkley here with Professor Fred Watson.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.